Hello, my name is Isabelle Richard, and today I'm going to be talking to you about the potential dangers of electronic cigarettes. So, first, I'm going to give you a background, then I'll address my research methods. After that, I'll talk about my future work, and at the end, I'll wrap it up with a summary about everything we've talked about. So, first, what are electronic cigarettes, or e cigarettes? Electronic cigarettes are handheld battery powered vaporizers which stimulate smoking. Two examples of types of e-cigarettes, the brands being Smock and Juul, are shown. These are metal devices which hold a liquid commonly known as e-juice, containing vegetable glycerin, propylene glycol, nicotine, and flavor concentrates. The device then heats this up with a metal heating coil. This turns it into a vapor which can then be inhaled, hence the term vaping. Pictured is a man by the name of Herbert A. Gilbert. He is an Australian man who developed the first model of the modern e-cigarette in the 1960s. It was created as a smoking cessation aid, yet was never commercialized properly and therefore didn't become commonly used at this time. Through many years, this model was altered and improved upon until it was introduced to the US in 2006, where it recently became very popular, especially in teenagers. Though electronic cigarettes are advertised as a safe and healthy alternative to other types of smoking, they have shown to have various negative health-related consequences. As a lab, we're trying to find exactly what about them poses danger. As of February 18, 2020, in the US, 2,807 cases of hospitalized e-cigarette or vaping product use associated lung injury were reported to the Center for Disease Control and Prevention. In addition to hospitalized lung injury, 68 cases of death were reported with association to e-cigarette use. As a lab, we're trying to find exactly what about electronic cigarettes poses danger so that these causes of injury can be eliminated as well as to make it easier to treat injury. Through my literature searching, I discovered a study which exposed electronic cigarette vapor to have concentrations of the metals cadmium, lead, manganese, nickel, and chromium. What I decided to look into specifically is the chromium found. Something you'll need to know about chromium is that it has different oxidation states. These states range from -4 and -2 to +6. The two most common types of chromium are chromium 3+ and chromium 6+, which is why they're the only types of chromium which would be present in electronic cigarettes. However, these types are very different. Chromium 3+ is practically harmless, while chromium 6+ is toxic, and inhalation of it has been shown to increase risk of lung cancer, as well as damage the small capillaries in kidneys and intestines. Finding out what type of chromium is present is called speciation. So this is what I decided to look into for my independent research project. I began to speciate the chromium to determine if the chromium found in the vapor of electronic cigarettes is toxic. To analyze the e-cigarette vapor to answer the research question, first we had to obtain it. How we do this is through the use of a peristaltic pump. Here we have a diagram of the process. An electronic cigarette is attached here with a wide flex tubing. Connected to that with parafilm is a thinner flex tubing. This is the part which is connected to the pump, which is in the back here. At the far end, over on the left, it's connected to a contraption of 4 pipette tips, which are then attached to a vial down here. This pump essentially exhales from the device first, causing it to be activated in most cases. The vapor then travels through the unit and collects in the vial. Specifically, my lab is testing Juul, Smock, and Vice disposable devices in the 3 flavors Virginia tobacco, mint, and menthol, as they're the most commonly used flavors. After collecting the vapor, we needed to actually speciate the chromium. Due to this experiment being relatively new in the way that we are using it, I first set to work on developing a method. The first part of the decided upon process is to use a high-performance liquid chromatography instrument. This instrument separates out particles due to charge within an anion exchange column, henceforth speciating it. How this starts is with the mobile phase right here. The mobile phase is what moves the sample, in this case the electronic cigarette vapor, through the machine as well as flushes them out. With a sample of electronic cigarette vapor being unique and not used in this manner before, I had to develop a proper mobile phase for it. Spent a lot of time literature researching this and decided on a mobile phase of nitric acid, as it does not break down the components of e-cigarette vapor and has been used in previous studies as an HPLC mobile phase. Once I created a mobile phase that works well for my sample, I began the actual chromium speciation. This worked through the pairing of two machines. The first being an inductively coupled plasma mass spectrometer, also known as an ICP-MS machine. This machine works by separating out particles through their mass-to-charge ratio. By doing this, we are able to identify and quantify the specific metal types in the samples we put in. In the specific case, that means it will tell us how much chromium is in the sample. We then paired it with the HPLC machine I referred to earlier to separate out the particles by charge. This gave us the oxidation level of the elements found, which leads us to the speciation of the chromium. Unfortunately, I was unable to run the samples I collected due to the outbreak of COVID-19. However, before we were unable to work in lab, I was able to run my control groups. Here you see how the data collected from the ICP-MS is displayed. First, you get a diagram where the chromium can be seen as spikes in the data, like over here and over here. This was for a sample with both chromium 3 and 6 in it. Additionally, you can create a chart with the exact levels of each in numerical form. If I were to run the samples, then I would compare the levels to my standards. In conclusion, electronic cigarette usage has recently exploded, especially amongst teenagers. This is problematic due to the negative health effects that they have been shown to cause. Through discovering the reasons why electronic cigarettes have this effect, we can then advance towards eliminating these causes. My lab specifically is looking into the chromium found in the vapor of multiple brands of electronic cigarettes. We are determining if this chromium is in the toxic form or not. I would like to acknowledge my mentor, Dr. Anna Rule, as well as two of my supervisors, Dr. Mina Turani and Dr. Jana Mihalik, for leading me in this research journey. As well as this, I would like to acknowledge the Ingenuity Project and Dr. Rosen for playing a large role in guiding me in this experience. Thank you for your time. Additionally, here are my references, and if you have any more questions about this project, you can contact me at the email isabelle.sl.richard@gmail.com.